All right, welcome everyone to the next iteration of our lives here at the Malibu Creator House. Today we're going to be talking all about AI agents, AI agent best practices. I think it's a really hot and interesting space. If you guys can, if anyone is in here, if you guys can give us feedback on the choppiness of the stream. If the stream is feeling pretty choppy, let us know. It's one of the things I want to just get feedback on real quick. So is the stream choppy, Grace? Like, or is it actually pretty good? All right. Yeah. Well, it'll probably be the same everywhere. But anyways, we're gonna roll with this. I think it should work. So, anyways, I want to introduce our two other people on here. You guys already know me. So we have Ryan Brandt and Justin Strong. These guys have been working with AI agents for the last couple of years, and I'm really excited to just get talking with people. It's saying quite laggy. All right, fine. All right, we will just eat shit on this then. 1 second. Just have it be terrible. Okay, we got to move him over though. Okay,
Okay.
that's super sad, but this is like honestly probably just as good. Okay,
Camera it is.
yeah, audio is fine though. Yeah, okay. Laptop camera it is. Yep. So you might want to move this down just a little bit. So there we go. So anyways, welcome. So can you guys introduce yourselves a little bit? Ryan, you want to go first?
Yeah, sure.
Yeah.
So my name's
Into the mic, bro.
my name's Ryan. Yeah, let me know. Okay, hopefully everybody can hear me all right. So
Yeah.
the last couple of years, I've been in San Francisco working on AI agents. Most recently, I was the CTO of a dental AI company called Dento AI, and it was during that time that I got really interested in the reliability and improvement loop for agents. And so basically, like, how do we know if these agents are working, especially as they're doing more and more important work and work that has stakes, and if the work is done incorrectly or poorly, like really bad things happen. And then how can we improve them? So I've been doing that work. I've done it for Fortune 500 companies at this point. I've done it for a lot of startups in the Bay, and it's a really exciting time to be building in this space.
Awesome. Yeah, Justin, can you introduce yourself as well?
Howdy there, everybody. I'm Justin.
A little bit closer to the mic.
Oh, okay. Let me bring this in. Hey there, everybody. I'm Justin Strong. Yeah, like Ryan, I was living in San Francisco for the last few years, and I've been really on the bleeding edge of what's going on in the AI world. Back in 2023, I sort of started this agent company. We were building a unit testing agent for developers. And we were doing something very, very similar to Ryan's approach with this, where I called it the sinking boat. He calls it axial coding. But in theory, it was basically we would run our agent and we would identify the most common failure modes of this. And we'd like categorize each of them. And we'd say, okay, so the unit testing agent today, it on this one, it didn't include the right import, or it wrote a unit test that was like plausibly impossible. And so we'd figure out all these different failure modes that it had, and we'd write fixes for them to fix the agent so it was useful to the user.
I love that. And I think that that's like one of the biggest things, like, at least for me, when I think about like AI and agents and this whole space is like, I don't trust them. I don't trust them because it's like they can literally do whatever the hell they want. Like, it's not like there's no, like, when you're looking at like an if else block of code, you're like, I know what this is going to do. Right. But with AI, it's like kind of different. So can you guys talk a little bit more about these failure modes? Because I think that's like a really like one of the most important things, right?
I'm happy to. So basically, every agent that I've ever worked with, the clients that I've worked with, there are always patterns of behavior that could be classified as like error or failure patterns. I think it's important to like taking a step back. It's part of the reason why this work is hard is because as any technical person will tell you, has worked on systems at scale, when things fail silently, it's really hard to detect that, right? Like, it's one thing if, like Zach said, there's an if else, and it's like really easy. If you have an exception and that exception's being thrown, I mean, that shows up on Sentry. That shows up in a way that's very easy to detect. You get a PagerDuty alert that everything's great. Well, not great, it's on fire, but at least you can see the fire and feel the heat.
Yeah.
With agents though, it's actually, I mean, these things can fail in ways that are really subtle. And I think it's also worth, at the top of this, coming up with a description of what failure even means. Your agent can be very helpful and very useful for the end user, but it could still be considered a failure. if it's not actually achieving the goal, the product outcome that it was made for. And so it's really a lot of my work is in figuring out both the combination of is the agent doing what it's supposed to be doing, and also what is the agent supposed to be doing. A lot of the times when I'm working with clients, like part of it is actually figuring out what is the most useful outcome for your business. Like you should have an agent that's actually performing that. And then we detect.
Yeah,
when it doesn't work.
That makes a lot of sense. I know one of the big things I teach in my AI bootcamp is around like in AI agents are similar to data pipelines in the fact that, like, you know, companies, they don't have just one data pipeline. They don't just have like a God data pipeline that like does all the data. It's a terrible design. It's just an awful, terrible design. And in a similar way, you don't just have like one agent that does everything, because you have the same problem, right? Where it's like the amount of constraints that you would have to think about and the amount of tests that you'd have to think about to like have, you know, almost like, you know, Sam Altman, he's always talking about like the AGI. Do you ever imagine like what the unit tests look like on AGI? Like,
I can explain it to you. I mean, I see in the comments here somebody saying, "Can you give a recent example?" I would be happy to, and happy to address what Zach said about how do you unit test AGI?
Yeah.
It's really difficult. But I think generally speaking, the idea is this is where you want to do something. It's a radical step. A lot of people don't do this, and it's going to sound crazy, but I'm going to ask you to look at your data. A lot of people are going to want to look directly at the dashboard, or they're going to want to look directly at like whatever eval platform that they're using. But oftentimes you need to just look at the data and actually see what's happening. It's like by far the most useful thing you can do. A recent example of like something that is an error, and maybe a unit test that you could hypothetically write for AGI. There was a leasing bot, a lease agent, right? It was like people would come in, they want to rent an apartment, and so they would talk to an agent, a chatbot, and that chatbot would help them with the process of renting an apartment. And so the person comes in and is like talking to the agent, asking about the room. The agent's like, oh, like here's all this information about the room. And it looks helpful. I mean, all the information is correct. It looks great. But the problem is that the agent itself didn't actually upsell them, didn't book an appointment, didn't do any of those things. So that's a failure. It's a quiet failure. Like everything looks good, but then you start looking at the data and you're like, okay, well, this is clearly why we don't have any appointments with our booking agents. It's because they never got booked in the first place.
Yeah, it's like the failure by omission, right? It's like, because a lot of people think of failure as like, oh, the agent like gave a 99% off coupon when what we wanted it to only give a 10% off coupon or something like that, right? Where they think of it as like failure by commission, as opposed to, because I think that's a big thing that like is kind of overemphasized sometimes, is like this area of like in LLM and AI is around like hallucination and the AI getting it wrong. But like, there's also the idea of the AI not getting it right. Right. And I think that's what you're talking about here is like, is this, and that's also failure. That's also failure, and probably like a more common failure than even hallucinations. Like
totally, man. I mean, if there's a hallucination and the person books the appointment and then the actual human who's there sells them on the apartment, that's a win for the business. Even if the agent had a slight hallucination. But the other thing is not true. So I think that, but like all of this is dependent on having somebody in the room who's like, this is the outcome we want from this agent. Because in another context, maybe for whatever reason, this is like an FAQ bot for people who actually live in the building. Then it doesn't make any sense for them to book an appointment with like a leasing agent.
Yeah.
So suddenly what was an error in one context is like preferred behavior in another. So you have to understand context is probably a word people on the stream are going to get tired of hearing. But it is essentially like these things really matter. You have to understand the same way with a person. If you're going to give a person a job, you would give them like instructions on when and why to do things.
100%. And like, I think a thing to remember here, and it's the way I kind of see the data engineering career like evolving, is because one of the things that Ryan said many, many times there was, look at your data, actually look at the data, actually look at what's happening, and looking at the traces, looking at the flows, looking at the logs, right? And like, that's like I know there's a lot of like nervousness around like what's going to happen with data roles and data engineering. And like at the end of the day, it's like, if you're just hearing it from the guy right here, he's doing AI engineering, on the job, making tons of money doing this. He's saying it's a data engineering job. He just literally just said that,
yeah,
right?
yeah. So yeah, let me be clear. Part of the reason why I love Zach's content and the work that he does as a creator is that he's right. I mean, like, whether you're doing it for pre-training and you're making that data prepared for like going into like actually training an LLM, or in the case of this sort of newly developing field, which I would call like applied evaluation, like agent reliability, that's also a data pipeline. It's, I mean, you need to, like in each case, you need to be able to understand and ask questions and derive insights from streams of data, and in some cases, very large streams. And that is like, by the way, the number one thing that I see in teams that have the best outcomes. It's like their ability to drive a disciplined process in deriving insights from their data. And that, I mean, you kind of need to be a data engineer to do that. So
I love that. So I want to get Justin in here a little bit. So like you're saying that you worked on like unit testing in this AI context, like, and so like how can you like when you're building out unit tests, what qualifies as like a good unit test for AI?
So what we were doing was actually the AI was writing the unit test, and
Ooh,
so
that's nice.
Yeah. So kind of the overarching, I mean, I guess.
Can it test itself? Is it like kind of like, can you build an
Yes.
AI that writes unit tests for itself? It's like a little, like, it's like a,
It was self-testing. It wrote its own unit tests. And it actually, the really cool thing, this was back in 2023 when AI kind of sucked, is it actually found bugs in itself.
Ooh, that's amazing.
It wrote unit tests that were like failing and was like, this should fail
Yeah.
because the code is bad. And it called out that we had made a logical mistake.
That's great.
Yeah. I mean, I think the overarching goal of that, like the context there was like, you look at the code, you define the correct test cases, and then you write those. And in 2023, that was really non-trivial.
So one of the things that I notice is like I've ebbed and flowed with the idea of unit tests, because like I think one of the things that can happen with unit tests is it becomes a false North Star, because of the fact that you have like, you can say like, we can only trust this code if we have 100% coverage, right? Or like we can only trust this code if we test every single possible edge case. And one of the things I've noticed is like I spend a lot of time working at Airbnb deleting unit tests, because I'm like, hey man, this unit test is making it harder to change the code, and it's like not providing value, and it's like just being super annoying, right? And so like there's this idea of like, I don't know, like almost like this, like, if you guys heard about like the idea of like the happy path, right? Where it's like you test like the 20% of outcomes that cover 80% of the behavior or whatever, and then that's all you write, and then you don't like, because I don't know, every time I worked in big tech and I came across the engineer personality who was like, we need 100% unit test coverage, I always fought with that guy. I fought with that guy every day, and that was the guy who made me quit my job. Like, I don't know, like, like it's a lot, right? Because it's a balance. It's a balance of like velocity, coverage, trust, and like these things all kind of like, they're all necessary, right?
I think that's kind of, as someone who like worked in the unit test space professionally, like, and I've worked with a lot of different companies. There's a lot of different competing opinions about the best way to unit test. And I wouldn't say there's like any one, right? It's all nuance at the end of the day. For some orgs, they're like at such scale, and like the cost of the incremental mistake is so high that like you just can't afford to have anything less than 100.
Yeah.
Probably for most though, I think your approach is probably the right one. Is where like we're like moving pretty quick. We don't want to like have constant regressions and like actual economic impact from that, but also like we can accept that like we're not going to test that like 0.01% of like use cases. Like we really don't care about that.
100%. And like I think that's like the like quality metrics, right? And understanding like if your agent is doing what it needs to be doing, right? And that's going to be one of the things that I think is important in this whole space, right? Is like, first off, like defining it. I think that was one of the things Ryan said earlier, is defining like scoping it, like what does it do and what does it not do, right? That's like, I think, and having a very clear definition of that, especially because it's like, I think AI and a lot of the marketing around AI is like, you can do anything with it, right? And it's like, yeah, you can, but like, it's a gigantic pain in the ass to engineer something with no constraints, like because it's like, there's going to be like, it's just really, really intense, right? So like, I'm just curious to Ryan here on this one. Like, what are some good quality metrics that people use when they're like, deploying these AI agents? I mean, obviously there's like a revenue, like what you're saying earlier, like if there's more booked flights and there's more booked or booked leases, like that's a good metric. That's a good metric. But like, is there other ones that people use?
Totally, yeah. And I just the idea that you put here, like I like the idea that like people use prompts to work with AIs, but companies use specs. They use specifications. Like they use like a list of things that the agent should do and should not do, and they're really specific about it. And so the original question is like, what should we measure to make sure that the AI is working? I think that there's like two things, right? There's like the ultimate outcome, especially in what is a multi-step agentic process. Like if you have like 4 or 5 interactions on average before like your happy path is done with, then yes, you can check based on the outcome. But if you have enough issues in between getting from the beginning to the end to the outcome, you might not really be measuring what is actually like the obstacle at the moment. So like, for instance, usually what you want to do in an agent is like figure out, based on the outcomes that you want, what is the first upstream error that you're encountering? And then you want to come up with a way to automatically detect that, both in like CI and production, so that you can so that you can like figure out when this thing is happening at scale.
I love that. That actually has an interesting data engineering like parallel, which is like when I talk with my a lot about like, so in SQL you have like the case when statement that they use a lot of times to clean up bad data, because there's like bad log data, and then you have like, you clean it up with a case when statement so it's mapped and conformed, right? So you guys need to be talking closer to the mic. Sorry, like that's just it only detects like
next time I'm going.
Yeah, for sure. Okay, great.
We'll get loud if you guys, don't worry.
Like, and so, but like, instead of like handling this gigantic case when statement, one of the things that data engineers often fail to think about is, what about fixing the logs? What about talking to the software engineers and fixing the logs so that we don't have a case when statement, and we can just read in the data directly and it just maps directly. And then like what you were talking about is like, what is the most upstream source of the error, right? And it's like, the further upstream that you can go, the better, because that solves the problem. That's like another phenomenon, right? There's a phenomenon called shift left analytics right now that's happening, where it's like data is getting pushed closer to the source, models are getting pushed closer to the source, and those things matter a lot. Those things, like if you can move the data and the models closer to the source, then like the feedback loop is way tighter. It's way tighter. Especially like, that's one of the things these LLMs are giving us, is the ability to do that, not have like the giant, like we used to have this giant loop where you have to like train a model and then get feedback on the model and then put that, and then feed that back through. And it's like this giant like 7 or 8 step process. And now it's just like data, it's like context, LLM. It's like very like the number of steps now is like a lot less. So like, highly recommend that idea of like always going to as far upstream as you can. That's going to be a very, very important thing to be thinking about, like as you're like going through this. So I'm going to do a quick speed run here, right? So one of the things I want to say here is with productivity tools, right? Because I know a lot of people, when they think AI, they think Claude, they think Cursor, they think Windsurf, they think like all of these. Like, what do you guys use, and like what do you think is important when you're working with Claude and Cursor and these tools to like be better and be faster?
Totally. So I'm super biased here. I think Claude Code is like one of the best tools anyone can use right now, and I'll tell you why. It's basically the best in class search right now. Like search meaning like, you give an AI some instructions and then it goes out, tries to fetch the data that's going to enable it to like do the task or answer the question. Like honestly, the best way to do that, it's like pretty simple. You just like throw a bunch of files into a directory, open Claude Code over it, start asking some questions. Like it'll grep its way through, or it'll do, like some sort of pattern matching the way a human would to like find the relevant pieces. And then it'll summarize and answer the question for you. I can't tell you how many textbooks I've done that with. I've like ripped a bunch of textbooks, thrown them in a directory, and then asked it like questions to reference everything. It's a massive unlock. Plus it can write scripts, execute them. Like you said, the feedback loop is just so tight.
I love that. I love that. Especially like I found that like at least I did a lot of like battery testing between Cursor and Claude Code because I was like in the middle between those two for a little bit, and I'm very firmly in the Claude Code camp now because like I just felt like Cursor I was like stuck in the IDE. I just love being in the terminal. I love being in the terminal. I love like just like having it there and then just like also comparing a couple tasks. I remember like it's so interesting because some of these things like Claude Code still fails on like the absolute largest tasks. Like, for example, like Data Expert is a Next.js app, right? And you know how
Yep.
Next.js has the two types of router. It has like
Yep.
the pages router and the app
And
router.
yeah.
And so like, and keep in mind, like I have like 95 pages on Data Expert. It's a lot of
That's a lot of
pages.
man.
So like
That's a lot of
what
pages.
so but like what I tried, I just wanted to see what would happen with the AI was I was like migrate everything from the pages router to the app router. That was like, and I wanted to see what I knew it was gonna eat shit. I knew it was not gonna solve the problem because it's too big of a task to like solve like for AI to just solve like that, right? And like I found that like there's kind of a middle ground, right? A middle ground of like you can't have AI like deliver too much code because it's gonna like the essentially every line of code that you increase the probability of some bug, right?
That's right.
Personally, I've found it at like 200 lines is like anything above 200 lines, there's usually something wacky that ends up happening. But like, I'm curious, you have any like guidelines on that? Either, Justin, you have any thoughts on that?
Actually, one of my favorite things to do whenever I try out a new model or a new tool is I'll do like escalating difficulty tasks. So I start with like something pretty easy that I know is like within the realm or the like domain of what's possible with the current tools, and then I try something a little harder, and eventually I kind of like see where it like cuts off. I'm like, okay, I know the end. And sort of actually part of what guides me in this idea is I saw a tweet from someone a while back and I really loved it and I wish I could credit their name. But it basically said like there's certain tasks which are above like the definition or capability level of a model. And when you find a task that's above that model's definition, like you need to like manually go in and specify it more. So
Yeah.
you've underspecified the problem and like so just can't pull enough definition out of that.
You know what's interesting about that is what you just described is actually the difference between a senior engineer and a staff engineer in big tech, right? So senior engineers are given defined complex problems to execute on. Staff engineers are given undefined problems, right? They're like, for example, like when I worked at Airbnb, it was here's pricing, make it better.
Yeah.
And it's like it's like imagine you put that prompt in the Claude's gonna be like, what the hell do you mean, right? It's like you need to have I put that in the Claude just to see what happened. Like give me a $1 million a year startup, make no mistakes. It doesn't know what to do. It like thrives with constraints. It thrives in that space, and I think that's actually where like it's terrible but also amazing is like if you're someone who is good at working with ambiguity and you're good at working through like you take an ambiguous problem and you turn it into a defined problem, that skill is still untouchable by AI. I think that's the thing that AI is not very good at doing yet. And that's the and I do think that's why like we're seeing this kind of divergence in the job market, right? Because we have like junior engineers who like really thrive in defined problems. That's their whole point, was to thrive with defined problems. And then senior plus engineers thrive in ambiguous problems. And so it's like it's complicated. Do you guys have any thoughts on that? Like, say you were like 22 today and you're trying to get your first junior software engineer role. Like, what would you be doing to like find those roles? Because they're kind of disappearing.
So this is an amazing question, and I think that
into the mic, bro.
Oh yeah, this is an amazing question. I think that first of all, I mean, let me acknowledge it's pretty tough out there right now. I think that like I've heard from people even like at the Ivy League, Yale, that are having a lot of trouble getting jobs right now. So it's definitely not just like a get good situation. Like there's definitely some like structural forces. But yeah, generally speaking, I think that you're not that far away from the frontier right now. Like if you put like 5-6 months of study into like agents, LLMs, how to use them correctly and how to improve them,
I mean, this is still such a new field. Like you don't have to have 10 years of experience to make contributions to it.
Yeah. Do you know what's so interesting? Like what you just said, I was literally at a call with my therapist today talking about all of this, or like, cause I teach data engineering and I also teach AI. And like the thing about it is like when I teach AI, I kind of feel like a fraud a little bit. Cause I'm like, I've only been doing AI for 2 years. Like I don't feel, but then when I teach data engineering, it's like I've been doing data engineering for 10 years. Right. So I've seen every possible thing go wrong in data engineering. And I know exactly like what to do and what are the best practices and everything. Like every single question, like there's not a question I can't answer in data engineering, but then in AI, it's like, I mean, students ask me a question every single lecture that I can't answer because it's like, it's right on the edge. And like, I have to study more. And it's like, it feels like I'm the student who's also the teacher, right? It's very like fast. The loop of me teaching these AI boot camps is very fast and very like intense because I'm like, is this what I'm supposed to be doing right now? And I mean, it's working, but it's a lot, right?
Yeah. And like 6 months from now, like some of those answers will be wrong. And
Yep.
and like it's like the field's moving really quickly.
Yeah, for sure. I mean, what so you say in this 6-month learning track, right? Of
Yeah.
like learning AI and agents, like what did you do to upskill? What did you do to like get into this and like dive into actually learning AI and agents?
That's a great question. I think the biggest, I mean, I'm a huge proponent of project work. So generally speaking, like do not like just hit the books and hit the books. Like actually try and build something that's useful. And I feel like that's way more motivating for me. I think that also you're just gonna run into problems like and see them firsthand. There's no substitute for that. But I think that one of the ways that I think you can probably like learn the most quickly is by trying to do like a multi-step agent that has like some sort of goal and it has maybe like 5 or 6 steps, maybe like an internal loop, and see how often you can actually get it to do the thing you want it to at the end of like 5 or 6 steps. Like for example, imagine you have like 3 or 4 tools in an agent and you have like a general like you have like a couple of different scenarios. Imagine like an executive assistant agent, right? Like you want to get availability for the person you're doing it on behalf of. You want to like figure out maybe they have preferences on like when you should schedule something, when you shouldn't. And just build that agent. Build that agent, see what happens. Or build an agent even better. Build an agent that solves a problem for you. And then because you know what the outcome is, see how it like kind of screws up and like iterate on it. But there's really no substitute for just like building something right now. The best advice I can also do, and Zach, I'm sure would echo this, is like post all of your learnings online because people need to see that you are learning this stuff. And I think that right now, high agency behavior is in short supply. And so if you can show like I'm self-directed, I have like learned a ton of things. Maybe I even learned some things that like experts know how to do, and I derived it independently. Like that, I think is really impressive.
100%. There's like self-guided learning is becoming even better, and like it's an interesting balance, right? Because I think that's like, we spend 22 years of our lives like in the freaking school system, like learning, and it's a cohort model, right? Where it's like we join 5th grade, 6th grade, 7th grade, and it's like very structured and very like not high agency. It's like, no, you have to learn this specific thing, not like you determine your path, right? And I think that's definitely one of the most important things to unlearn as like you're going into this new world. Like or just keep doing it. Like, I mean, and that's why I like cohort. I like cohort because like I also think that there's not like that unlearning process is not for all personality types, that unlearning process is for like 5 to 10% of people potentially, like, and then everyone else really likes that's the reason why college is so like the number of self-learners versus the number of people in college is like, like almost 2 orders of magnitude different. So like it's very interesting. It's very interesting how this world is like shaping up. So like, I guess one of the things I'm wondering about is like, so when you're working with tools, right? One of the things you're talking about there, Ryan, is like, so a multi-step tool agent, right? That does stuff, right? Like one of the things that I know my students are really wowed by with my boot camp and data expert is I have a RAG model that like what it does is it takes a student's submission and then it grades it.
Yeah.
Right. And you know what's so crazy about that RAG model is I don't use a vector database at all.
That's, by the way, probably what you should be doing.
Yeah.
Not so, to be clear, you should not be using RAG for that. I think you're probably doing the right thing.
Well, it's like, well, because there is but it's still technically RAG, because like, I mean, when I think of RAG, it's just like you have a prompt, you have a basic prompt that you augment, right?
Yeah, you're retrieving dynamic context.
Yeah. And so like, but the context is like literally like a rubric, which is literally just like, a string in Postgres. It's like, here you go, here's your rubric. And then there's the other part of the context is actually really nasty, because it's like you have like a zip file, right? And the zip file is complicated because it's like some of that context is text, some of that context is image, some of that context is PDF, some of that and it's like, and so like the hard part of constructing this, it's like, it's very different from like setting up RAG. RAG is actually really easy, but I find that like this problem was actually, I've been iterating on it for like a year now. And like what I found is that like getting that right of like, okay, here's the prompt, here are all the files relevant for this prompt. And I actually, because getting it to be able to like review like data design diagrams and data architecture diagrams and like all of this stuff, that was like a lot of work. But like once I got it to work right, I was like, wow, this just works for freaking anything. And it's like, it is actually pretty amazing like what you can do with this stuff. And like I want to get it to a point where I actually sell that as like a service potentially, even, right? Where it's like that, just that alone is worth something. Where it's like, give me a zip file and I'll give you feedback on your zip file based on some sort of system prompt. And it's that easy, right? And so like it's going to be interesting though, because I think what I learned from that is like not all RAG needs. I feel like RAG and vector database are unnecessarily married. I think RAG is amazing.
Totally.
Yeah, RAG is super amazing. I'm not as much of a fan of like doing the cosine similarity matching. Like I feel like every time I'm got into that space, I always build something that is like kind of annoying to work with. It's kind of like do you have any thoughts on like how to make your vectors more relevant or like
yeah, there's some good content out there about that. I think Jason Liu has a course on Maven, which is pretty good. Zach, I'm sure would be able to teach something similar. I think that like generally speaking, you're right that like vector databases I think can be difficult to work with. There's a lot of levers, right? There's like, because at the end of the day, what you're doing is you're throwing a bunch of unstructured text in there. And then, like you said, like there's some sort of embedding model. And so you're encoding all of that text, unstructured text, into vectors. And then you take a question or a query and you also encode that into a vector. And then you use some math, cosine similarity, to see like how similar was the question to what's in the database, which sounds great. But then, you have to understand like you in any vector database, you really have two things you have to consider. One is for every single document that has information that is like relevant to the query, how many of those are you picking up? And then two is of those documents, which one is like actually the one that has the answer to the one that would, because those are not the same thing. They could be related, but not actually have the answer at all. So I think that, people have come up with various solutions to solve this. There's like re-ranking, which is like typically done, you try and figure out, okay, well now I've retrieved 5 or 10 or I usually K is the variable that stands in.
Yeah, top K. So the number of vectors, so Ryan's talking about like the number of vectors that you retrieve when you do an embedding match. So that's called top K. That's like the first knob that you really have to work with. Yeah, keep going, Ryan.
Yeah, and then you can re-rank. I think that, so like you can do things, I think, to have better results. A lot of the times people will have like some sort of eval system, and they will check to see whether or not the LLM is spitting out the right answer. And if it's not, then like, then it's not working. That's actually a common misconception. You should not have your RAG tests be LLM tests. They should not be. Like instead, what you should do is you should have like a ground truth data set where you have like a bunch of unit tests, quote unquote, where you have a bunch of queries and you know exactly the documents in the corpus that relate to it and have the answer. And then you just tune your retrieval. So it's like, okay, well now like I will like run a unit test that says that, and before you run the test that like 3 or 4 document IDs are relevant in that corpus. Then you run it and see whether those 3 or 4 document IDs are in the top K. And if they, and also are they like at the bottom or at the top? And so you can kind of tune your retrieval that way. It's cheap, it's easy, it doesn't require an LM as a judge. And also, you know, the LM isn't going to tell you anything because like if the correct information never makes it into the context window, then what are you testing? you're not really testing anything. So you want to just make sure that you have unit tests at the retrieval level that like actually determine like, is retrieval working?
Yeah.
And that for vector databases.
Yeah, I love that. I love that. I guess that's not really a unit test though, right? That would be an integration test, right?
I
Because
think
you're actually hitting the vector database and like what's actually in there.
so it definitely has IO. You could
Yeah.
call it an integration test in that like it does not, if it relies on some sort of third party data store or data structure, then yeah, you could call it an integration test. Maybe I'm calling it unit test in this context because it's probably like the smallest unit of test that you could do for like a vector DB setup. So that's like the atomic unit. But then there's also like, you can also do other types of tests on it. Like there's chunking, right? Like how are you chunking things in the DB? What about the metadata? Because you can have like actual metadata associated with each vector and use that to, you know, help like structure the query to do like BM25 keyword matching on the metadata as well as
it's like it's not, you're saying like mixing like sparse and dense vectors there a little bit.
Exactly. Yeah. Exactly.
That's great. I mean, so like, I guess one of the other things, so you're saying re-ranking is another big one, right? Re-ranking, that's one that like I've found to be pretty useful.
Re-ranking is super useful. I think ideally we wouldn't have to re-rank at all because our retrieval would be so good that we would just always get the right thing out of the DB. But I think re-ranking is sort of an acknowledgement that like we're not always going to do that. And so let's have a layer in there to make sure that we can correct any mistakes we made at the retrieval level.
And I think that there are some queries in particular where re-ranking is better suited, especially when you have like negation queries, like give me all the things that are not in the ingredient list, give me all the things that like or it's like both negation and temporal. It's like, what is the rules in 2023? Because 2023 is a pretty freaking common token, right? So it's like you'll probably get all the rules lists for maybe the last 5 years, and it's just going to match on all of those. And then the LLM can re-rank and find the correct context from the top, right? So like, I guess with re-ranking, like, because you want noise, right? You have noise and then you go to clarity, right? It's like noise to clarity. Is that like is there any, do you have any thoughts on like is there any like rules of thumb here on like in terms of like what % you should throw away or what % you should keep? Or
that's
like
a great question. So I think that I mean, there's these like axes here. So there's like recall, which is like, is there like of the total number of documents that have anything to do with the query, how many of them are we retrieving? And then there's relevance, which is like which one of that set, like how many of them actually has the answer to the question.
I love that.
And those are actual, those aren't like theoretical, like there should be numbers associated with each of those axes. And so I think that the reason why it's important to have axes of measurement is that then you can start to answer questions about like, what is a good rule of thumb? It's like, okay, well, like how is our system performing on those axes? Like if I know I have 100 documents total, and then I ask a question about like hot dogs and it brings up like 5 documents, but there were actually like 5 more documents that had the history of like bratwurst, which is kind of related to hot dogs. Then maybe it has a recall of 50%. But of the documents that were retrieved, all of them were like very specific about hot dogs. Then maybe your relevance is 100%. So you just want to make sure that you're like, all of this is like, I think I found that like you can get lost in the terminology. And I think that all of this is really in service of like getting the actual answer into the LLM context so that it can do something with it. Yeah.
I love that. Like, I guess with these knobs, right? Is that something like, I guess one of the things I've found interesting when I've been building RAG systems is like, it feels like you just pick one number for all queries, like your top K, and then you, like how like, so your top K is one number, and then your re-ranking is another number, and then you have to divide. And like I'm wondering like have you ever played around with the idea of like where you determine top K based on the query that's coming in, or like is that something that you do, or like or is it mostly like you set one number for the API and you just like you're good?
I think that it's so that's again, that's a really good question. I think that this is, I mean, this is the sort of thing where like there's no one size fits all answer. I think that you're like, this is partly like sort of going all the way back to the beginning of the conversation about like look at your data. Because like let's say you have like a really specific vector DB corpus. Like in some cases, maybe your K can be really low. Because there are a lot of like very highly distinct things in that database and like a relatively small number of articles or unstructured chunks about each of those things. And so it's like, we don't even need re-ranking because there's only like 3 or 4 things in the DB that are, but like in other cases, maybe you do need re-ranking. And I think the key is like, can we quickly run experiments that like give us concrete numbers that we can use to make decisions? So like if I run K at 10, am I able to tell like recall and relevance and be able, and then also like move that against like cost, right? Like how much more expensive is this? Because I think that that's, you just basically want to be able to make decisions based on those numbers, like not based on any like gut feeling. Like you want to be able, because otherwise it's easy to spin your wheels. Like it's nice to be able to just be like, what is like the optimal intersection of like the cost of this, like cost of all of these tokens going into the LLM window, and also like how accurate is it?
I love that. I love that. Like, so one of the things I know people love to talk about all the time is like what happens when you have a billion vectors, right? And like what happens in the space of like where you're working at like, Netflix scale, even though, 99.9% of y'all are never getting there. But it's like, it's interesting to think about like how things break down and like how things need to be searched, right? At least like in my, research, it seems like there's like essentially 2 ways that you can kind of like index, right? You can do like it's called like HNSW, like it's like the nearest neighbor graph way of doing it, or you can do like IVF flat, like that's like the other kind of way of indexing. Like, do you guys have any thoughts on like when you should use those, or like what is your opinion on the, or should you just use like something like Pinecone or Quadrant that kind of does these things out of the box?
I mean, again, I think that so there are a lot of techniques that do a lot of things. I think that and it's so easy to get bogged down in what levers do I pull. I think that for any lever, you just want to make sure you have a good understanding of the outcome you want, and is this pushing me closer or further away from my outcome. So I think that, like for instance, like indexing usually used in the context of like we need a performance like a latency thing. Like we usually need our results more quickly because the query is taking too long or it's too expensive or something like that. But for vector DBs, sometimes maybe that index has like some trade-offs. Like if it's like nearest neighbor, then maybe you're not covering the full search space. Like maybe, so I think that you just need to be able to you just need to be able to like make the decision based on what your specific situation is, and there isn't a one size fits all answer. I think generally speaking, yeah, use Pinecone, use Chroma, use a PG Vector. Big fan of PG Vector, because then you don't have to have 2 data stores.
Yeah,
but like
PG Vector is great. That's why I moved. I was using Milvus in V1. I taught Milvus, and now in V2 I use Supabase and PG Vector.
Yeah,
because it's free. Everything's free. It's so easy, right? And it's just one data store with everything. Like, 100%. So one of the things I want to do is we want to open up the channel here a little bit to any Q&A that people might have about what's going on here. So like we're going to open it up for questions for about 10-15 minutes. So if anyone has any other thoughts, we'll do that. We'll just let them kind of like think about it. We'll probably have just a little more discussion here while people are thinking about that. Totally. So one of the things that I'm wondering about with like agentic behaviors, right, is that like, so you have tools, right? So, right. And one of the things that I was talking with Chip about, and she really opened my mind to this, is like this idea that like it's possible to give your AI too many tools.
Oh my
right?
God, yeah.
Like, and like, can you explain a little bit more about like when that happens?
Totally, yeah. I even have a concrete example. So I think that there's a couple things to keep in mind when you're doing tools. I think that what does the LLM know about the tool that it has, right? Like it has a description of some kind usually, and then it has like some understanding of what parameters go in. And so this is actually a really common failure case is, you know, the tool itself is like not in the same file as the prompt. And so people are, you know, they're putting all their time and energy into refining the prompt, making the prompt better. But then it turns out I look at their tools file and it's like, this tool is like really not very descriptive at all. And it's unclear to me when you would want to use this. So I think that like, there's one, like, are your tool descriptions useful and descriptive of when they should be used? And that should always be like one of the first places you look. If you have like,
I love that.
If you have 15 tools in an agent, I'm going to go out on a limb and say that's probably too many tools. I think that your agent should always be constrained to a relatively small number of tools that it knows when to use in the right scenarios. If there are tools that do similar things, oftentimes it can be kind of a coin toss or a coin flip of when it's going to use tool A versus tool B to do something. I think a good rule of thumb is it's kind of like, if anyone's familiar with security, there's the principle of least permissions, which is essentially you should never have more than you need. Right. So you should make sure that you are optimizing for the minimum number of tools to accomplish the goal that you want. Because again, just think of it. Imagine you give somebody, it's a person, and you give them like 10 different hammers that look kind of similar. You know, don't be surprised if they like use the wrong hammer for a job because they're tough to tell apart. I think you have to treat these almost from the eyes of like having some empathy for what it would be like for a person.
I love that. Like, because I think that like one of the things that's very interesting about this new world, like what you're talking about, is the description. It actually matters a lot. Like, because it's so like, much. I feel like if you go back 3-4 years ago and you talk to an engineer about like how important is documentation, they'd be like, it's okay. I write self-documenting code. That's what they'll say. They'll say, I write self-documenting code. And in this new world, like the actual documentation of the tool, the actual description of the tool affects functionality. The documentation is the functionality. Like they actually are connected. They're connected. Like
code is documentation.
Yeah, it's very new. So yeah, if anyone has any questions, we're taking questions for about the next 10-15 minutes. So go ahead and drop them in the chat and we will get to you guys as soon as we can, right? Oh, we actually have one from Parva here. Parva has a good question here. Which is we'll put it up there. How do someone break into this field? So Justin, you want to take this one?
Oh man, I mean, I've never been professionally employed to build agents. You know, I just started doing it one day and then raised money and, you know, off to the races I was from there. But if I wanted to break into this field anyways, some of the things I might think about is, can you contribute to open source? So I come from like the, code gen world, and there are a bunch of these open source code gen agents. Can you just start contributing to those projects and building impressive features or things? Like one thing you can look at is like, is there a success metric that the team in that open source project measures? And can you hill climb it? Like, can you make an improvement, an incremental improvement there? Because if you can, that is a great project to show on your resume. And similarly, like there are other like open source projects that are very respectable libraries and such. And if you can contribute to those will stand out in a resume filter.
Yeah.
And there'll be great things to talk about also, because an open source project is effectively a team that you can contribute to and work with. That is pretty permissionless. I mean, obviously you need to like get buy-in from the team, but you get to work with a group of people without having to like go through hiring committee.
100%. And I think for some of y'all, if that sounds super intimidating, you need to learn the fundamental skills there. There's a couple fundamental skills there. One is probably going to be like Python. Most of these libraries are either written in Python or JavaScript. Claude is an NPM package, which I always find so crazy that it's like you have to have Node to use Claude. But like, anyways, also super important is open source is all based on Git and GitHub. If you don't have a GitHub account or Git, then you need to learn just the absolute basics of Git, because that's like Git is the language of collaboration. Git is the language of open source. And so like if you can't like know that language, you can't speak the language of engineers, then like you're going to have a tough time. So those would be the fundamentals to then like be able to feel confident enough to like actually go and make an open source contribution, which I totally agree is a very, very valid way to go about it.
Yeah. I mean, even before you can go do that, you might need to just do some self-education.
Yeah.
I
Take
mean,
a boot camp. Take my boot camp.
Yeah,
Ooh.
if you're not the sort of person who has like the agency, like we were talking about, like if you don't have the agency to like go out and self-learn, like that's probably one of the best levers you can do, because you're not going to learn this stuff in college. I don't
Yeah.
think many colleges are teaching this.
Oh, yeah. Colleges aren't even teaching data engineering, bro, and it's like 10 years old. Like it's 10 years, and I'm like, dude, like college, you guys are like freaking so far behind,
Yeah.
right? So, this is another question from Lubo. He says, "What's the optimum number of tools you've seen work best for a private internal AI agent?"
So that's a great question.
I think that so the only reason why private / internal would matter would be like if maybe you're using a model that is less powerful because it's private, and internal you're using like an open source hosted model. A lot of those are pretty decent now. I mean, like Qwen is pretty good.
Yeah.
And you know, RL is also becoming more feasible for open source. So they're getting pretty powerful at punching above their weight. But assuming, unless you clarify the private internal thing, I'll assume that you are. I'll just answer the question as a general thing.
Yeah.
I think that if you have, I mean, you could probably get away with 10, but it's worth asking yourself why. Like, what exactly? Because at the end of the day, like, think of it this way: you want to have behavior that's reliable. Like, if I ask an agent to book me an appointment, I want it to book me an appointment like 100% of the time. I don't want it to sometimes do things I don't expect. And if you have more tools, then it may do things in different combinations that are like a little bit surprising to you. So I think it's worth like making sure that you have like highly specialized agents that that do really specific things and achieve very specific outcomes. And I think you'll have better performance doing that. It's tough to put a number on it because like, but I wouldn't. I mean, 10's probably pushing it. Like I would keep it on the lower side.
Yeah. In my boot camp, I say like I say a dozen. I say a dozen is like the absolute like ceiling. And like, but like again, it's like one of those things. I have a follow-up for you, Ryan. Like, so what you're saying is highly specialized agents, right?
Yes.
So is there like a way that you do like agent orchestration here where you have like an I don't know, like some sort of orchestration agent that it's that agent's job is to figure out which agent to go to?
Totally. Yeah. I mean, that's a good routing technique. And I think that like ultimately, I think it depends on. I'm probably going to. I'm going to probably sound like a broken record, but it depends on the outcomes that we're talking about here. So like, if my general rule of thumb as a first principle is fight against complexity as like a first order antagonist. So if there is like ever complexity where you're like, this is cool, like for sure experiment with it, but if it's going to be deployed to production, like let's be ruthless about cutting it down. I think that orchestrator pattern makes a ton of sense for like delegation to agents, especially like longer running agents. If you have like one, tools can be agents too. I think that's worth, and that's kind of the same thing as like what you're saying, Zach, but like that can be like the orchestrator pattern. Like you can have tools and those tools kick off other agentic processes.
Yeah.
And you have maybe like 5 or 6 of them and you call that tool and then that triggers another. So I think that you just want your agent to be like, to give you a concrete example, for that like leasing bot that I talked about earlier, like probably you would want, you know, maybe even in context, not even as a tool call, you would just have like information about the space, this sort of stuff that like you wouldn't need to retrieve context for, like general information about the building. Maybe you have a tool that like gets information. If you give a particular room, it just retrieves like a room number. It gives you a particular, like gives you the full set of context for that. And then a tool for booking the appointment, and then a tool for canceling the appointment and rescheduling. But even like in that case, like you might think like, okay, well, I've given it all the tools it needs. There was a case that was kind of famous where there was this leasing bot is like actually existed, and it had a tool for scheduling and a tool for canceling. And people were like asking it to cancel the appointment, make a new one. And I think the exact term they were using is rescheduling. And instead, it never canceled. It just made 2 appointments. So suddenly their leasing agents twice as booked, but 50% no shows. Like you may have to, first of all, that's unless
Yeah.
you're like doing the interrogation process. But second of all, like know that like as you add more tools into the equation, they're going to combine in unpredictable ways. And that is a large surface area, like the number of permutations to cover. So complexity is your enemy at this stage.
Yeah. I love that. I love that. That's like a, it reminds me of the quote, like, simplicity is the ultimate sophistication.
It is.
Right. And
It
that's like,
is.
that's how you actually get to like where you're trying to go. All right. Oh, this is a good one from Carlos. And this is probably a good one to end on. So we say, Carlos is saying, what are the limitations of agents? And philosophically speaking, how do you make sense of them?
Man, it's a great, it's like the greatest question I don't know how to answer, because there's so many ways to answer it, like societally, from a very technical, concrete standpoint. I'm gonna assume you're talking about concrete because there's plenty of more qualified people to talk about the societal effects of like intelligent software. But I think the big limitations, there are two main types of errors in LLM driven development. There are specification errors, meaning like, okay, the AI did something that we didn't expect or we didn't like, but we never told it not to do that. So we're gonna, we'll look at the prompt, notice we never actually gave it instructions not to do that, update the instructions, maybe it doesn't do that anymore. The second are generalization errors, meaning that we did very specifically tell the AI not to do this, and it did it anyway, in some strange circumstance. And so the limitations of AI are always going to be generalization errors, because specification is more of a it's more of a you problem. It's like, okay, well, I wasn't specific enough. But generalization is always going to describe the area that is where agents run into limitations. I think that, and then combine that with like some agents, maybe OpenAI is talking about agents that run for hours, days, months, weeks, years. I think that's another limitation right now, is that like I think that the amount of work that can be done that is useful and high stakes is like still pretty low right now, because all of these wacky mistakes can happen. And so like from a very concrete economic sense, I think that there's a lot of trepidation at like the Fortune 500 about there's lots of retrieval agents. There's lots of agents that'll tell you anything about your data. Very few agents that are like hiring and firing unilaterally with like no.
Yeah. They're not just like, we're just delegating any big decision. That's another big thing I talk about, like in terms of like, when you're thinking about like, will AI take my job? Right. Is like, because when I think about like the data stack, right? So you have like data analyst, data engineer, data scientist, right? And so like in that stack, right, the data engineer is actually pretty safe, because we're not going to have AIs build pipelines, because then like if bad data goes around, like we're cooked, bro. Like there's still a lot of risk in doing that, like especially at the highest levels of data engineering. They're not going to delegate that work to an AI. Definitely not. All right. But as you go further down, or you go to a data analyst who's like looking at dashboards and looking at trends, and like what you're saying, retrieval agent, which is like, tell me everything I can know about my data.
Read only.
That is like that becomes like, and it's a lower risk role, right? Because it's like the cost of failure isn't high. Right. And if the cost of failure is high, that's where those roles are going to stay human for a longer period of time than the roles that the cost of failure is low. And so like, definitely you want to be thinking about that as you're like going through your career, is like, how can I get to a position where I'm trusted? Because enterprise trust and enterprise like risk are connected, and like they're also connected with compensation. Because like for me, right, I was making great money at Airbnb, right, but I also owned every pricing number. Every price that you saw on Airbnb, I own that number. That was me. And so like that has a massive impact if it's wrong, if it's wrong, that has a massive impact, and they're not going to delegate that. So like, I love that perspective, Ryan. So anyways, thank you guys so much for tuning into the live today. I hope you guys learned a lot. I learned a lot. So we're going to be back here live tomorrow at 4:20 with Grace Angelica. It's going to be really amazing. We're going to be talking about LinkedIn branding and how to build this, creator brand. It's going to be really, really fun. Make sure to follow these guys on LinkedIn. This is Justin Strong and Ryan Brandt, BRANDT. I hope you guys have a fantastic time. Thank you so much.
See ya. Bye. Volker, DM me. I'll answer.